Alright, this video will be about acidic, basic, or neutral substances, how to identify them, and we'll go into pH and pH calculations. So, an acidic substance has more H plus concentration than OH minus concentration. Right? You have three ways to identify an acidic substance. An acidic solution has less OH minus than H plus concentration. An acidic solution has more H3O plus ions than OH minus ions. Right? It's pretty easy to just, when you are asked to compare the concentration of H plus and OH minus in an acidic solution, the H plus concentration or H3O plus concentration, these are used interchangeably. This is a hydronium ion. It's going to be, in an acidic solution, these concentrations are going to be more than the OH minus concentration. And also these brackets, just a reminder, these brackets mean concentration. So instead of writing concentration, you could just put the ion and put brackets around it to say concentration. That's how you read it. So H plus and H3O plus can be used interchangeably. So if you write H plus concentration is greater than OH minus concentration, that's right. If you write H3O plus concentration is greater than OH minus concentration, that's also correct, because H plus and H3O plus are interchangeable. Right? A basic solution is a solution that has less H plus concentration than OH minus concentration, or has more OH ions than H3O plus ions. So the concentration of H plus is going to be less than the concentration of OH minus. Or if you want to write the hydronium ion, H3O plus, concentration is less than OH minus concentration. In a neutral solution, the concentrations of H plus and OH minus are going to be the same. They're going to be equal. This is a neutral solution. Alright, so this is a great visual, and also it has a pH scale just as a way of showing the pH and how it's related to the H plus concentration and OH minus concentration. So as you can see here, the relationship between the H plus and the pH is inversely proportional. So as the pH decreases, goes from 14 to 13 to 6 to 2 to 1 to 0, the H plus concentration increases. Right? You could see here, when the H plus gets bigger, that means the concentration is increasing. All right? So as you can see here, as the pH decreases, the H plus concentration increases, and vice versa. As the pH decreases, the OH minus decreases, but as the pH increases, the OH minus concentration increases, and the H plus concentration decreases. It's an inverse relationship between H plus and pH. Okay, let's do alright, so this is just a quick review of the pH scale. So an acidic solution has a pH of anything lower than 7, so it could be 6.9999 to 0. A basic solution has a pH value above 7, so it could be from 7.001 to 14. And a neutral solution has exactly a pH of 7. Right? So a pH of 7, that's a neutral solution. Okay, and again, this is just a reminder, the inverse relationship. As H plus increases, pH decreases, as you can see here. As H plus increases, so it goes up, the pH decreases. It goes from 14 to 0. And as H plus decreases, see, as it gets smaller, and smaller, as the H plus decreases, the pH increases. It's an inverse relationship. And this here shows you a pH scale, right, showing you some common substances. So you have your stomach acid has a pH of 1, coffee has a pH of 5, so coffee is acidic. Milk has a pH of 6, so it's slightly acidic, right? Tomato juice is 4, it's slightly acidic. Apple juice, lemon juice is 2, a pH of 2, so it's acidic, okay? Soap has a pH of 10, so it's basic. Baking soda is basic. Bleach is basic. Ammonia is basic, right? And also Drano is also a basic substance. So if you can see the pattern here, most of the washing solutions, washing liquids, are basic substances. All right, and then pure water is exactly at 7. That's pure water, right? That's water, H2O, distilled water with no ions in it, no minerals in it, has exactly a pH of 7. Okay, so that's the tap water, right? But distilled water is a neutral solution or a neutral substance. All right, so pH calculations. There are 2 ways. You have the regents level way, and you have beyond regents, which is AP chemistry, college chemistry, and honestly just chemistry in real life. All right, because you're not gonna have a perfect you're not gonna have always a perfect number like the regents questions give you. All right, so the regents level way of calculating pH is equal to so you have to find the concentration of H plus, convert that into a scientific notation, 1 times 10 to whatever number. The number that is base 10 here, the exponent, is going to be the pH. So if the H plus concentration was equal to 1 times 10 to the 6 or to the negative 6, right? Let's say this was the concentration of H plus, the pH is going to be right here. It's going to be 6. If you have a concentration of H plus that is 0.004, no, not 4, because we can't use this, 0.001, convert that into a scientific notation. So 1, 2, 3. So it's going to be 1 times 10 to the negative 3. So this 3 here is going to be your pH. It's going to be 3. This is the pH value of a solution that has 0.001 concentration of H plus. Okay. All right. So in a solution, right, sometimes you're gonna see questions that give you the H plus concentration, but some questions will give you the acid concentration, not the H plus. For our purposes, for our regents purposes, our curriculum purposes, we will always give you a strong acid, and the concentration of this acid will be the same as the concentration of H plus. Right? So if HCl is a very strong acid, so if the concentration of HCl is 0.001 molar, the H plus concentration will also be 0.001 molar. If the concentration of HCl is 0.0001 molar, the concentration of H plus will also be 0.0001 molar. It's going to be the concentration of the of H plus is going to be the same as the concentration of the acid. Because we use strong acids when dissolved in when added to an aqueous solution, they will dissolve fully, and the concentration of H plus will be the same as the concentration of the acid. All right, so when you see a question that gives you the concentration of HCl, right away that concentration is also the concentration of H plus. All right, so let's do some examples here. The regents level pH calculation only works if the scientific notation has exactly 1 in front of the integer power of 10. Right, so if it has exactly 1 here, see, like here, in front of the times 10 to the whatever power, right? That's where you can use the Regents level way of calculating pH, right? So pH is going to be the exponent basically of the 10. So if you have an HCl solution that is 0.1 molar, right? When you convert that into scientific notation, right, you move the decimal place once to the right, so it's going to be 1. So first of all, HCl is 0.1. The hydrogen ion concentration is going to be the same, 0.1. When you convert that into scientific notation, you're going to get 1 times 10 to the negative 1, right? So the pH is going to be the exponent. It's going to be 1. So for this solution, the pH is 1, right? If you have a solution of HCl that is 0.001 molar, right, the H plus concentration is going to be the same, 0.001 molar. When you convert this into scientific notation, right, moving the decimal place 1 to 3 places to the right, you're going to get 1 times 10 to the negative 3. This 3 here is going to be your pH. So for this solution, the pH is the exponent, which equals to 3. Okay. All right. So you can try these on your own. Here, if you have, so here I gave you the H3O plus concentration or H plus concentration. Remember that we use them interchangeably. If the concentration is 1, the pH, or in scientific notation, this is 1 times 10 to the 0, and the pH is going to be 0 because it's the exponent. So it's a very strong acid if it's like that. That's basically just H plus in a solution, nothing else. If you have H3O plus concentration of 0.1, when you convert that to scientific notation, it's going to be 1 times 10 to the negative 1. So the pH is going to be the exponent. It's going to be 1. Right. If you have H3O plus with a concentration of 0.01, the scientific notation is 1 times 10 to the negative 2, right? Because you move, so excuse me, what is going on here? Okay, so you move the decimal place twice to the right, right? And then you write it 1 times 10 to the negative 2. The exponent is going to be the pH, so pH equals 2. I'm going to do one more, and then you can try the other ones on your own. So if you have an H3O plus concentration or H plus concentration of 0.001, you're going to convert that into scientific notation. So moving the decimal place 1, 2, 3 times to the right, you're going to get 1 times 10 to the negative 3. And your pH is going to be the exponent, which is going to be 3. You can try the rest on your own. I'm going to give you the answer. I don't know if you can see it, but it's faded. I hope you didn't see it because it will give you practice. But basically you convert and then you get the pH. So the pH here, you could try this on your own. You could pause the video, try this on your own, and then come back. So the pH for this solution here will be 4. pH for this solution will be 5. pH for this solution will be 6. Okay. So if let's see one here so if the H3O plus concentration is equal to 0.000000001, what is the pH? Okay, try this on your own. Alright, so to do this, you're gonna have to first convert this number into scientific notation. So let's see. So you're gonna move your decimal place 1, 2, 3, 4, 5, 6, 7, 8. 8 times to the right. So it's gonna be 1 times 10 to the negative 8. And the exponent is gonna be your pH. So the pH of the solution is equal to 8. Okay. Now let's go to beyond Regents level. For beyond Regents level, you have to use this formula here. pH equals to negative log H3O plus, or remember that we use these interchangeably, so it's either H3O plus or H plus. Okay, so this works with any concentration. It doesn't have to be a perfect 1 times 10 to the exponent. Okay, it could be 2, it could be 2 times 10 to the something, it could be 3.5 times 10 to the whatever. All right, so let's do some examples here. Just remember, when you plug it into your calculator, you're gonna put negative. You're gonna find the negative in your calculator. You're gonna find the log, and that should open a parenthesis. If it doesn't, put a parenthesis and then put the concentration of the H plus. Okay, and then put the H plus concentration, and then press enter, and that will give you the pH. Okay, so I'm gonna do the first two here. What is the pH of a 0.00345 molar aqueous solution of HCl? Okay, so our formula is pH is equal to negative log of the H plus, and remember that the H plus concentration is equal to the acid concentration. So HCl is the acid, and this concentration is also going to be the concentration of the H plus. It's going to be the same thing. So you plug this into the formula, negative log, the H plus concentration is 0.00345. When you plug this into the calculator, you will get, let's see here, 0.00345. This will give you 2.46. You could keep it to the nearest hundredth place, right? So this is your pH for this solution, for solution number 1. For number 2, what is the pH of a 0.00468 molar aqueous solution of HNO2? Right, so this is the acid, this is the concentration of the acid. So the concentration of H plus is gonna be the same. It's gonna be the same concentration here. So pH equals negative log of this concentration, 0.000468. You plug this into your calculator, negative log of 0.000468. This will give you, you could do this on your own, and then it will give you 3.329. Around it to the nearest hundredth, so it's going to be 3.33. Okay, and notice here, if you try to convert these concentrations into scientific notation, this will be so 1, 2, 3, 4. So moving the decimal place 4 times to the right, so it's gonna be 4.68 times 10 to the negative 4. Right. In this case, this is not 1. If this is not 1, you can't use the regents level method. You can't just say pH is 4. You have to use the formula negative log H plus. All right. Same thing here. If you convert this into scientific notation, it's gonna be it's gonna be 3.45 times 10 to the negative 3. Okay, because you move this decimal place 1, 2, 3 times to the left, so negative 3. You can't just say the pH is the pH is 3, because this number here is not a 1, is not a perfect 1. Okay, so you have to use the log formula. You could try to do these on your own, number 3, number 4, and number 5. All right, and I'm gonna do them with you in 2 seconds. All right, so pause the video, try them. Alright, I hope you paused the video and you tried them. So I'm gonna do them right now in my calculator. So this is what is the pH of a solution of an that has a concentration of 0.00968. You plug this into the formula. Alright, so it's gonna be negative log of 0.00968. Plug this into a calculator, and it will give you 0.00968. This will give you a pH value of 2.01. Right, so number 4, you plug this number into your calculator, negative log, right, of this, and you will get, let me do this on my calculator. Negative log of 0.00468, and this will be pH is 3.33. Oh, it's the same thing as number 2. All right. Number 5, you could do it the Regents way, or you could do it using the formula. So you could use the formula negative log of, this is for number 5, negative log of 0.0001. This will give you, let's see, negative log of 0.0001. This will give you a pH value of 4. Okay, you could use the formula for calculating pH, or you could do it the Regents way, which is convert to a scientific notation, which is going to be 1 times 10 to the negative 4, and this exponent is your pH, so pH is equals 4, right? But whenever you use the formula, it works with any concentration. It doesn't have to be a perfect 1 times 10 to the negative integer.